Okay, so yesterday we talked about frame of reference and relative motion. Are we all good on that? Any questions over that? I've got some stuff about that on the quiz. Today we're going to do a multiple vector diagram, and we need to talk about displacement versus distance, because there's a big difference in the two when we're in physics. So distance versus displacement with vectors and motion. So I'm going to talk about displacement first. And some things we need to keep in mind about displacement. Displacement and distance are not the same thing. People often confuse them, but they're not. Displacement is always a straight line path from start to finish. Or it might say start to end position. So think about this. Whenever you leave here tonight after practice, right after school, whatever, the bulk of you drive home in a car. Does your car measure your displacement? Okay, I'm seeing some yeses, I'm seeing some nos. Does your car measure your path in a straight line? No. So it doesn't really measure your displacement. Wouldn't it be nice if we could drive everywhere in a straight line? We'd get everywhere much quicker. But your car doesn't actually measure your displacement. What does it measure? Yeah, total distance covered, and there's a big difference. We think of this displacement, if we're going to define it, another way to define it is change in position. And we must remember it includes direction. So we have to think about that. It includes direction. The symbol for displacement looks like this. This change in position, it is a delta x. And this triangle is delta, which stands as Greek letter and stands for change in. And x is the symbol for displacement. I can find my displacement or my change in position by using delta x equals x sub f minus x sub I. What do you think x sub f means when I'm talking about a position? Anybody have any idea? The f? What'd you say? You said something. Yes. What'd you say? Finish. What's another word for finish? What did you say something? Final. Final's a little shorter. We'll use that. So this is final position. And this I in physics, F always stands for final when it's a subscript. And this I in physics always stands for initial when it's a subscript. And they show up a lot. So later, like next week when we get into word problems, you might have to use this. You might want not, you're going to find, personally, I love an equation a lot more than I love drawing vectors. Vectors help us understand where we're going. Equations let us figure things out a little more quickly. Lana? Is it what? It's like this. X sub F. Yeah. Okay. All right. So, displacement versus distance. If I look at these two things side by side, let's do that. I'm going to draw an arrow under each one. If you're doing vector diagramming and you're talking about displacement, you're going to measure, I'm going to put that in parentheses. You're going to measure a straight line start to finish and convert with your scale. If I'm measuring distance, it's something different. Let's look at this. Everybody have a ruler? I'm going to have you do this with me. Let's say, I'm just going to make a little vector diagram here. And we're going to say, for you guys, let's say, we'll make this easy. 1 centimeter equals 1 kilometer. So we can whip through it pretty quick. The first thing I want you to do is go 7 kilometers, 0 degrees. So, I'll think this through. I'll just kind of start about here. I need a ruler. Oh, I get the junky ruler. Okay, then we're going to turn and we're going to go 3 kilometers at 270. So everybody put that in. I'm a little off there, I can tell. So this was 700 kilometers. This was 300 kilometers. What? Yeah. Oh, kilometers. I put 700, sorry. I see what you're saying to me now. It should be 7 and 3, not 700 and 300. Okay, so now on my next vector, I'm going to go 3 kilometers, 0 degrees. 3 kilometers, 0 degrees. So I've got another 3 kilometers here. All right, now I want to go 10 kilometers at 90 degrees. 10 kilometers, 90 degrees. So I'm going to add that. Wish I could see. That's about 10. And now let's go 3 kilometers, 180. So 3 kilometers, 180. I'm going to run into my key. And then let's go another 3 kilometers at 270. Okay, so I have this lovely path. when I finish, each one of these represents an individual vector. Let's see, I said this was 3 and this was 3. But I want to know the displacement. Kennedy, how would I find the displacement? Fletch, how would I find the displacement? What's the displacement, Cole? No, don't tell me it. What does displacement mean?
It's the starting position to the end position.
Straight line from start to finish. So how do I mark that? I do this. And let's see. You draw a hash line like this. And my ruler keeps moving. I'm having a little trouble. And then I say R equals. What does R equal? What'd you get? I don't know what I got. Oh yeah. That's pretty good. Who said 8? 8 kilometers. Does yours match that? Luke, did you get about that? Ava? Now what's my problem? What is my direction? How can I do that? Use my straight line, use my protractor if I had one, and measure my degrees. If it were down here, I'd have to come all the way around. What'd you get? Oh. 39 degrees. That seems reasonable. 31 degrees. All right, big enough to see. Could I also say 8 kilometers northeast? It'd be actually, I would say 8 kilometers north of east would be the best way to say that if I wanted to say direction. Does that make sense to everybody? If I wanted to say east of north, I'd have to subtract this from 91, or from 90. Does that make sense to everybody? Because 90 is up here. If I wanted to know this angle, I would have to subtract 31 from 90, and then I could say east of north. That's exciting, isn't it? So, I have a resultant, I have a direction. Can you find the equilibrant? Find it! You got it, Fletch? What do you have?
-8 kilometers southwest.
What if I want real degrees? Andrew, you got it?
211.
Yeah, 211 degrees. I will specify if I want degree reading when you do one of these. If not, it is okay to just give me northeast, southwest. All right, now, here's your challenge. What distance was covered? What you got, Maria?
16 kilometers.
Okay, she says 16 kilometers. How'd you get that, Maria?
I just added up.
You just added them up. Okay, let's do that. This one was 7, right? 7, 10, 13, 23, 26, 29. Did you leave a couple out? Maybe. Did you get 29? Really? Did I do something wrong? 7, right? The first one was 7. Plus 3 kilometers is 10. Plus 3 is 13. Plus 10 is 23. Plus 3 is 26. Plus 3 is 29. I can add. How's that? See the difference? Now, think about this. I gotta think of something here. Think about a fountain at a park. So there's a system underneath that the water comes out of. It comes out of the fountain, it goes back in, and it filters back down. What is the displacement of the water in that fountain? What do you think, Maddie Maxon? What do you think, Evan? It starts here, oh, it fountains out, it filters back around. What's the displacement? 0. I'm back to my original position. What's the distance, Lucas?
A lot.
A whole lot. I didn't give you any numbers, did I? A whole lot. Yeah, you would have to know the path. So you have to think about them like that. It happens all the time in everyday life. You move a lot. Like, let's say you come to my room and you don't have your book because you guys never bring your books, and then you have to go back to your locker, and then you come back to my room. What's your displacement? 0. So you have to think about the path. Did you travel a distance? Absolutely. Don't let the two confuse you. Now, this is what I want you to do. You have a paper that you picked up